Yeah, yes. Lastly, which database are we going to be working with?
Okay, so for now, we can just start with SQLite. It's a file-based database. So we can just use that for now. And then afterwards, I'll show you how to integrate Postgres into your Django code.
Okay, so we're not going to be going to MongoDB.
No, I do not think. Let's just use Postgres.
All right,
We'll use
all right.
Postgres, yes.
All right, thank you.
Okay, like you are familiar with MongoDB.
No, I'm actually familiar with SQL and MySQL. So I was actually thinking of venturing into MongoDB because I found out recently that Python can also,
Yeah, you can actually connect to any database of your choice
Python.
if you want.
Yes.
Yeah.
Okay, that's fine. Yeah. All right.
All right, guys.
Yeah.
So last week, Samuel taught you guys how to install Python on your systems and he gave you a demo. You guys already have Python installed on your system? Am I correct?
For me, yes.
Does
Yes,
everybody
you're
hear?
correct.
Yeah, you can just type if you are not going to speak. Okay, so now we're just going to like jump right into the basics of Python. So this week, we're going to have 2 classes. That's this one today and another one tomorrow. So the one for today, that's today's class, we're going to be learning keywords and identifiers, variables, data types, type conversion, operators, and string functions. And then on Thursday, we will learn list methods, dictionary methods, conditionals, and looping. So I know some of you are already familiar with these concepts, but we'll still go over them again. Yes, so let's go straight, right? Does anybody, okay, let's just go straight right into it. So, excuse me. Okay, so let's start with keywords and identifiers. What are keywords? So in every programming language, there are some words that are reserved or restricted. So they usually have a designated function or functionality in that particular programming language. And we also have those in Python. So keywords are reserved words that have special functions. So we have about, I'm just going to, Samuel, can you click on the link there, please? I'm just going to show you some of the keywords. We have about 33 of them in Python 3. So I know some of you already know some of these keywords, but they are if, else, elif, try, catch, finally, except, with, return, function, no, def, actually, no function, def, class. All of these are reserved keywords. So keywords, we can go back to the slide. So keywords cannot be used as identifiers. So say you want to name a variable or a function or a class, you cannot use any of these keywords. That is why we call them reserved words. And in Python, keywords are case sensitive. That means that when you are using a keyword, you do not, all of them are actually in lower cases. So you have to use them as they are. If you capitalize a keyword when you should just use a lowercase, then you're going to like get an error, or like your code will not work the way it should work. So identifiers, like I said before, are names that we give to variables, functions, classes, and any other objects in our Python code. So let me show you what, let me just go through the rules for naming identifiers first. So the first one is that identifiers can have any length. We can have any length of characters for identifiers. It can be a combination of letters in lowercase, uppercase, or digits. So, or an underscore. So you can combine any of these. However, our identifier cannot start with a digit. we cannot use special symbols in an identifier. And like I said before, a keyword cannot be an identifier. So I'll just like present my screen to give you like, to show you what that looks like. So just give me a second. Let me quickly present my screen. Okay, so I just have this file here where we can just do some of our testing. So like I said, if you want to like name a variable, for example, you just say the name you want to give to the variable, for example, count, and then you say 5. Then you've assigned your variable like that. You've assigned a value to your variable. So this word here, count, is an identifier. It is used to identify a variable. So just as we all have names to identify us or distinguish us from other people, we also have identifiers. So identifiers should be unique in whichever namespace we are working on. And like I said, we cannot have special symbols like this. Your Python interpreter is going to scream at you. So let's try and run this code, see what happens. So you see, it gives this syntax error, invalid syntax. So you should not do this. However, you can use underscore, you can use 1, 2, 3. That's like fine. You don't get squiggly lines or anything like that. And then I wrote 2 tips for you there. So in the slides, you should give your identifiers meaningful names. So instead of just saying, let's say, for example, you want to store the name of a person, and you just put n is equal to the name of the person, say Mendy. Like, this does not make sense like that, because if you come back to your code after some time, you might just be wondering what this variable is for or is storing. But then if you give it a meaningful name, like name, or if it's a first name, you can say first name. Then if you come back to read it, you know that that particular variable is meant to store the first name of maybe a user or something. Okay, and then like I said, your identifier can be of any length. So don't say you're trying to like manage. There's no need to manage space or anything. Make sure your identifier is as descriptive as possible. Okay, excuse me. Okay, and then if you have like multiple words for your identifier, just like I did here, you can separate them with an underscore. So don't just, let's say I want to store something like name of school. And I write Mendy International School. So if somebody looks at this identifier, the person might just get confused as what is all this? But then if you separate them, it's very easy and clear to read. Like, that makes more sense. Okay, so that's that for identifiers. Then we'll go to variables. So when you are writing your code, you need to store data so that you can use them later on. So let's say you want to, let's say you have a username, for example. Let's say username that you want to make use of later on. You want to make use of this username later on in your code. Maybe you want to print it out, or you want to return it maybe in a function, or you want to send it to the database. You can just keep it inside of, you can just store it in memory. and then you retrieve it later. So like what you store here in this variable can be used later on in your code. So when we run that, it just prints that out. So we want to like not look at variables as like containers that just keep code for like just hold on to a particular value for like forever. Variables can store a particular value and then maybe get reassigned to another value later on. So you can look at them as tentacles, like octopus tentacles. So they can pick up a value and then after some time discard them and then pick up a new value. And also, like I used here, this equals to sign, which I used to assign this value to this identifier, is called an assignment operator. So I use it to assign this value baddest MC to this identifier here. So like that's how to assign a variable. So that's that. Then in Python, we can do something called multiple assignments. Say we want to, on a single line, we want to assign 3 different variables like age, class, and oh no, can't use class. Can I use class? Age, track, and maybe let me use name again. So you want to assign all of these values on a single line. You can just say age 12, then you can say track, Python track. Then you can do name, current. So this is how you assign multiple variables here, like in a single line, you just do this. And then when you print out the values, you can see that they've been assigned. And that's that. Also, you can do something, you can also like do chaining of assignments. I don't know, I think that's what we call it. So you can chain an assignment like this. Say you want 2 variables to store the same value. Say dozen and 12. And you want both of them to like have the same, 12. You want both of them to have the same value. What you just do is you just chain them like this. And then you put the value at the right hand side. So that's that. So dozen and 12 now like equals to the same value. I hope that's like clear. Hello? Is that clear? I can't hear anybody speaking. No.
Karina, can hear you.
Okay. So I just want to know if you are following, and like I did not leave anybody behind.
Okay, guys. So if you're following, can you just indicate by saying something?
You guys can just like say yes or something like that. Is everybody following? And I hope I've not left anybody behind. Is there something, if there's a concept you don't understand, please try to. Okay. All right. So then we'll go straight into operators. So operators in Python are simply they're simply symbols that we use to carry out operations or manipulations. So the value that the operator operates on is called the operand or operands. But it can be one or two. It can be 1 or 2 operators. So we have the following operators. We have arithmetic operators. We have comparison operators. We have logical operators, bitwise operators, assignment operators, identity operators, and membership operators. So I'm just going to do a demo of like how all of these operators work. So So say let's start with assignment operators. We'll start with addition. So you can just do something like 2 plus 2, and then it's adds the numbers together like that. So you can also do like your basic, you can just do your basic mathematical operations like 22 minus 11, that's subtraction. You can do 2 times 4. You use this asterisk when you want to multiply. So you can do 2 times 12, gives you 24. And then you can do modulus. So modulus is like to like give the remainder of let's say division. So let's say we have 23 modulus. Use the percent sign. So like the value that like gets from like the remainder is 1. So when you divide through with 22, you get like 11 remainder 1. So that's like what modulus does. And then you have this floor division. That's this double backward slash. So what this does, it's like it returns the integer value of a division. So instead of getting something like 11.5, you just get the integer value. They also call it integer division too. And then we have the power. That's if you want to do 2 raised to power 3, you just do double asterisk, and then it just works like that. You get it. So that's basically that's basically arithmetic operators. We also have comparison operators. Comparison operators are for comparing values, like the name suggests. So they always return a true or false value. So let's say we want to, let's start with the less than. So we want to do let's print this one out. So let's say we have 2 is less than 3. If 2 is less than 3, it's going to print true, and 2 is less than 3, so it printed true. So it's either returns either a true or false value, or a Boolean value. So if you have 2 is greater than 3, which is not true, you get false. And then you can also do greater than or equal to. You get false because 2 is not greater than or equal to 3. But if you do less than or equal to, you get true because 2 is less than 3, although it's not equal to 3. Then you can also use the equal to operator. So if the values are equal, then you get a true value. But then if they are not equal, you get false. So if they're not equal, you use this not equal to operator, and then you get a true value. And then yeah, that's that for comparison operators. So you can use them to, so let's say you are trying to, let's say you get an input from a user, and then you are trying to validate if that value is equal to what something you're expecting. So let's say you are getting a value for, let's say you are checking if a user is active. So if the user is active, we're storing it as, so let's say a user is active. Let's say we're storing it as active. And then let's say user is active. Or let me say user status. So let's say user status is active, and you want to know if, you want to test to know if a particular user is active, you can just say print, you can just say user status equal to active, and then to tell you if it's really active. But then if the user is inactive, then you get a false. So you can use that to like determine what next to do in your code. So that's that. And then we have logical operators. So logical operators also return true or false. they also return true or false. So there is a truth table for that. So true and true is true. True and false is false. True or false is true. Then false or false is false. So there's a truth table for that in case you want to make use of that. I mean, you're going to make use of that later on. So you can check it out later. I'll drop a link for you to check it out. So we also have bitwise operators. Bitwise operators are like they operate on numbers as if they are binary strings. So there's bitwise and bitwise or not, shift right, I guess, and shift left. So those are like the bitwise operators. And then we also have assignment operators. So I've used an assignment operator before, like we have here in this code here. Then we also have, let's say you want to do some, let's say you have a value like number equal to 23, and then you want to print out 23 plus 3, or you want to assign number to number plus 3. Instead of doing number equal number plus 3, you can just do this, like put a plus sign in front of your equal to and remove number and add the value you want to add to it. Sorry. So by the time you print number, you get 26. So if you can also like do a minus in front of it. So like it says, what this means is simply number minus 3. So number is equal to number minus 3. That's basically what that means. So when you print it out, you get 20. You can also do for slash for division, then you get value. You can do for times, and say number equal number times 3, and you get the value there. Okay. Just push here. Okay. So yeah, that's that for assignment operators. Why are you moving like that? Okay. So we also have identity operators. So identity operators are basically if you want to check if a value is a type, you use it to check if a value is a type of a particular class or data type, and you also use it to check if a value is in the same memory location as another value. So usually Python does something to like optimize storage allocation. They call it interning. So for values like, let's say you have a value like this and another variable, let's just call it 23 and 23 and 3. No, call it the same value. So if you print number 1 is number 2, you get true. That's because both of them are pointing to the same, memory location. So like, how do you know if they are pointing to the same memory location? Just do this, use the ID function, sorry, to print, to check which memory location it is, and then you have number 1. So like they are being stored in the same memory location. But then this is going to work for small values like 23. I think it also works for bigger values too these days. Let me try 257. Okay, so that works. But then if you use it for strings, it will also work, like hello. Because like they are the same value and then they're also stored in the same memory location. But then if you use it for a list or an object, like a list object or a dict object, they will not work. even if they have the same value in it. Okay, so that doesn't work. Also, okay. Also, you can use the is operator to check the type of, like, if a particular value is of a particular type. So if we do number one, let's say type of number one, let's type, use the type function to check the type of a variable. So if you say type of number one is, this is a list, so it's just a list. Let's see what that gives us. So that gives us true. If you check if it is not a list, it will say false. Then if you have, say, a string like this and say is list, to tell you it is not false. I mean, so that's what basically use is for. Use it to check if a value is of the same of the same type with a particular class, or if maybe they're like equal to, like for integers and strings, of like that. For integers and string, you will not use them for bigger objects like lists or dictionaries or any other type of objects, but they work for strings and they work for integers, I mean. So we also have these membership operators. So use membership operators to know if a particular value is inside of another value. So let's say we have this list here. I'll just call it my list. And then I want to know if one is inside of this list. So I'll just say one in my list. So it's a list. Then it gives you a true value. So, but if you put a value that is not there, you get false. You can also use it for a string, like to check if a value is in a string. So if h in string, we get a true value. And then if you try to check for a value that is not there, it will give you false. So that's that. And then I hope I did not lose anybody in the process. Is everybody following?
Yes.
Yes.
Okay, so we also have Python data types. So Python, like you likely be dealing with so many types of data in your, like, while you are working. So you might want to store text, you want to store a collection of items or a stream or like an array of items. So Python has different categories of data types that like helps you to present or represent your data. So we have numeric types: int, float, and complex. So int is for integer values, float is for floating point values, and then complex is for complex numbers. Then we have booleans, that's bool type. So there's true and false value. So, and then we also have sequences, like a stream of data of characters. So we have string, we have list, we have tuple, and we have range. And then we also have mappings. Mappings are like key value pairs. So that's like dictionary, something similar to what we have in JavaScript that we call objects. So we're going to like look through all of them one by one, but let's talk a little bit about data types. So basically, data types are like classes. They are really not, they're not like okay, let me just say they are classes. So whenever you create a variable, you are actually creating an instance of that particular class or type. So first, let me show you how I already showed you how to get the type of a particular value or variable. So let's say we have track is equal to Python. So you want to check the type or the data type of this variable. You just do type, use the type function, and then you put in the variable there. So let's see what type the track variable is of a type string. You can see that this is a class str, so it's of a type string. So this is actually like creating an instance of this class. So track is like an instance of this class. I'm sure you must have heard people say that everything in Python is an object. So like this is part of what we mean. And let's try like an integer value. So number is equal to 23. So let's see what type it is. Is of class int. And then once you have a decimal point in a value, it's automatically, sorry, I'm just supposed to put a number there. So it automatically just becomes a floating point number. So it's of class float. And then we have complex values. Let's just add G at the back. And then, oh, okay. And then you can see it's of class complex. So that's that. And then we can also have, let's try for a true or false value. So admin is equal to true. You can see it's of class bool. And then that's same with false too. So just to be sure. Yeah. So, and then we can have, okay, we've tried for string. Let's try for list. So let's do my list. So you can see it's of class list. Even functions too. So let's see. Functions are also objects. So let's see. Okay, no, I'm not talking about functions. I'm talking about data types. So excuse me. So then let's also try for objects. So dictionary actually. So let's do name. And then we have page 10. The type is of type dict or class dict. So that's like that. We also have a non-type. So let's say you want to declare a variable, but you do not want to store anything inside of it yet. You can just say, you can just assign it to none. So if you check the type of my dict, you see it's of class non-type. So like I said, all of them are classes. All the data types are actually classes. And when you create a variable, you're actually creating instances of those classes. Like I said, we can use the type function to know which class a variable or value belongs to. You can also use is instance function to check if an object belongs to a particular class. So let's say this say is instance my dict non-type. Okay. Does that work? Let me see. Okay. I can't remember how to use this for none, but let me try with a normal dict. Okay. Let me quickly check that. Okay, it's supposed to be inside of it. Okay, so that works. So you can use this instance to check to check if the type of a particular object or variable is any of the data types you have in mind. So in fact, let me just remove this variable and just do a string like this. Just yeah, true. So that would non-type again. Okay, I think I'll just check this up later on. So that's that for types. So in Python, there are times when you like, let's say you want to add a value. Let's say you're adding a value like 1 plus 2. These are like two integers. So let's say we're adding a value 1.1 plus 2. So like this gives us 3. But what if we are doing 1 plus 2.0? You notice that the value becomes 3.0. So what happens here is that Python is going to do an implicit conversion of the type and then return a floating point. So like usually floats are higher than integers because like they have higher as what to use. So like they are more precise. So like 2.003 is more precise than just 2. So in order to like preserve the value or like the extra data, Python is going to like do a conversion from of the first value from integer to float, and then you're going to get your result in float. So but except you want to like explicitly cast that particular value, then you can do something like this. You just use this constructor and then you put the value, like this int is going to convert 2.04 into an integer value. So except you explicitly say that, then Python is going to just do it itself, and you get, or even if it's the trailing, like just zeros that trailing, then you're going to get a floating point type of value. So explicit conversion is also known as typecasting. Like it is you that have to say, it is you that will say, okay, I want this value to be a particular type. However, although Python does implicit conversion, it does not just, it's still a strongly typed language. So let's say you have something like that. I'm sure if you do this in JavaScript, you're going to get true because this value is going to be converted into a string by the interpreter. But then Python does not allow that. So like it will just scream that this operator does not support these operand types. So except you explicitly say, I want this value to be a string or an int, that is when it just like it's able to add them for you. So I think that's that. Okay. And then we have we also have, like, we've talked about arithmetic operators already. So these are the 7 arithmetic operators that you have for number manipulation in Python: addition, subtraction, multiplication, division, floor division, modulus, and power, like I said earlier. And then, okay, so that's that for that. So I don't know if you guys have questions based on what I've said so far. Do you guys have questions?
For me, no, actually.
Does any other person have questions?
Yes, I do.
Yeah.
Yeah, my question is that, sorry, it's about the code editor.
Okay.
So is it that we are going to be using PyCharm, or we are going to be using VS Code? I actually got all you said today. I just want to clarify that.
Okay, you can use any editor of your choice. I use Python because that's what I use to work. But you can use VS Code. I think if you already have the Python interpreter installed, you just maybe can set it up there's some plugins you can use to set it up to make it like very easy for you to code. But if you want to use PyCharm, you can get the community edition on their website if you like it. But then you can still use VS Code. There's no problem.
Okay, but which would you advise? I think that's English.
Well, like it doesn't really matter actually. I use VS Code. I use PyCharm because it has other functionalities, but you might not need them now. Since you're just starting out, you can just keep using Python, and then maybe when you want to work on a serious project and you think you need PyCharm, then you can go ahead. But for now, we can just use VS Code.
Okay, thank you.
All right. Does anybody have questions? Okay. Have you guys ever tried to do like add a value like this? Like, let me do 0.2.
Yes, I guess.
What happened? What happened?
What did he give me, Seth? He gave me something really odd. I can't exactly remember.
So like when you do like
0.1
0.1 is equal to 0.3, it gives you false.
Yes. So,
And other people confirm in their own editors. But then is 0.1 not equal to 0.2? Zero 0.1 plus 0.2, I mean, is it not equal to 0.3?
mathematically, yes.
It's supposed to be
Yes,
true.
but Python says it's false.
Why does Python say it's false?
Because it actually what's the word? It brings up the result of 0.1 and 0.2 in like almost 10 decimal places, right? Which is according to precision not equals to 0.3, which is 1 decimal. I want to believe that's
actually. Yeah, so but then I think the other things, like, it's not really Python's it's not really a bug, or some people say it's a bug with Python. It's not a bug with Python. It's more like how hardwares or computers do computation. So computers like work with just zeros and ones, and the way they deal with floating point numbers are like they make use of binary representations or binary fractions instead of decimal fractions. And so by the time you equate, like when you look at what a binary fraction is going to like results in, like with 0.1, you get a value that has, like, by the time you bring it into the numbers we understand as decimal fractions or decimal numbers, it's going to be approximately 0.1, but then it's not like equal to, and then Python is just going to pick the first ones. So like that's just 0.1. So by the time you like say by the time you do that for 0.22, so like it's not going to be very, very, it's not going to be precise at all. So by the time you add them together, it's not like the same value, because there's still like extra values at the back that you're not seeing. So it's not going to be equal to, even for decimals, if you do something like 3/10, you're not going to get exactly 0.3 or 0.33, because like 0.33333. So, but then for this particular one, it's because of it's the way the hardware represents floating point values, not a bug with Python. Does that happen with JavaScript? Have you guys tried it out with JavaScript? Yeah, okay.
Yes.
So it's not like from our interpreter, please. Python is it. Anyway, I think we'll just be moving on to strings. So I also said that strings are sequences. So they're just sequences of characters. In Python, if you want to declare a string, you just, let me just say my string is equal to, you just put a single quote or you use double quotes, and then you write whatever string you want to, my string, for example, and that's your string. So these strings don't like really matter, like in the real sense, they are just telling the interpreter where your string starts and where it ends. So that's strings. And if you want to like do multi-line strings, say you want to, because if you do this, oh, my this thing is already configured. Okay, so if you want to have like multi-line strings, you just have to do 3 double quotes like this, and then you can have as many lines as many lines as you want. So that's, but then it's still going to just print it like a normal string, like without the lines you're seeing there. Or you use double quotes. So like you can either use double quotes or single quotes, like I said, but you have to be consistent in your code but basically just so it can be, just for readability purposes. So just be consistent. If you're going to use double quotes, use double quotes. If you're going to use single quotes, just stick with them. Yeah, so then strings are just like arrays. I said they are sequences, so they're just like arrays. So you can access them the way you access arrays. However, they are immutable. So let's start with accessing them. Let's say, just call this kangaroo. And then let's say I want to access the first value or the first character. I want to access the first character in this string. What I'll just do is say my string, and then I'll use square brackets like this, and I'll do 0. So just like in lists or in arrays, the first position or the first character is at position 0. So if I print that, I'll get the first value, which is like K. But then you cannot, why I said string is immutable, you cannot say my string 2, is equal to P, and then, P should be in quotes, and then you now say, let me print my string. Like you just, string object does not support item assignment. So you cannot change the characters of let's say you want to change one character, you now say, okay, let me change what is in a particular index. It doesn't work. What you can just do is to reassign. So If you say kangaroo is not spelled kangaroo and it's KP kangaroo, you just have to do this. And then your string is going to be the new string. Okay, so I did not say that, I forgot to say that the data type of a variable is set when you assign it during the point or at the point of assignment. So because Python is dynamically typed, you can the value of a particular variable can be of any type. The type can change throughout or during the or let me say during the execution of the code. So let me say it like this. At this point, I can have my string equal kangaroo, and then the type of my string, as you know, is string. So let me do this. But what if I now change my string to an integer? But if you print the type of the string here, you would get an integer. So it's not like other statically typed languages where you have to like say, okay, this particular variable is going to contain just integer values, and that's going to be the data type for like the rest of the code, like throughout the process of code execution. So like that's not how Python is. Although it can be a bit tricky if, let's say, it can be a bit tricky if you are expecting a particular value from a variable, and then you're now getting, let's say you're expecting a string from a particular variable, and then you're now getting an integer. So it's likely because that variable has been reassigned to another data type. But then I think Python has something they call that allows you to like drop hints for your variables. So let's say you just add a semicolon, I guess, so you can say what type you want. So this is how it should be. So you say what type the value should be, or the variable should be. But then it is not a do or die thing with Python. It's not a do or die thing. You can still change the value of the variable, or the data type of that variable later on. And then yeah, I think that's it for that. There's something I remembered and I've forgotten again. So back to strings. Okay, back to strings. So when Python has built-in functions that can be used on strings. So some of them are capitalized, lower, upper, len, strip, replace. There are many of them. So let's just do a quick demo of these Python strings. So let's say we want to capitalize this string kangaroo. We just do, capitalize my string. So if we print that, you get why is that not working? Give me a second, let me check. Okay, it's actually string dot capitalized. Okay. So it's actually my string dot. Okay, yeah, my string dot capitalized. So, and then it capitalizes that. Or if you use upper, it returns the uppercase value of the string. or you do lower. So these are like important because there are going to be times when you want to compare values. Let's say you want to store, like in your code, you want to store emails or email addresses, and then you do not want to have repetitions. Let's say you want to store a value like karen@gmail.com, and then you do not want to have other you do not want to have a repetition of this email. You want to make sure that it's consistent, so somebody can come and still register with karen@gmail.com, or maybe it is capitalized somewhere, but then you want it to be consistent, and you want the data you have in your database to be consistent too. That is when you make use of all of these. That's when you make use of these capitalization or lower. So by the time you say, okay, let's see if this value is in our database first before we even allow the person to register. So because it is already in a particular case, you don't have to bother that, okay, another value with a different case is going to now show or something like that. So it helps with consistency, basically. And then we have length. So say you want to find the length of a particular string. You just do length of string, and then it tells you the number of characters in the string. So you can also do strip. Say you want to remove all the white spaces in a string. So want to remove the white spaces in a string, you just strip it. But then if you don't strip it, you just get what you give us. You have the spaces there. You have the white spaces there. So I think there are like two versions of strip. There's like R strip. I think R strip strips the one. Okay, it strips the trailing white spaces, and then L strip strips the leading white spaces. Yeah. So what if you want to replace let's say you want to replace a string with you want to replace a character with another one, and since we cannot reassign items or characters in a string, you can just replace the value. And then white strip is very important because it also helps with data consistency. So you don't want to have this value with spaces before them and then have another value like this in your DB. So you want to be sure that, okay, this value does not have any white spaces. So in case somebody with, let's say, this particular email address comes to register in your site again, in your site again, then you will not you will say, okay, this user already exists. But if you don't strip it, you just have this, you just say this particular value does not exist, and then you maybe get an error trying to register this user again. So that's that. So with strings, we can do concatenation. So same with our with what we had in our same with our addition operator. So say you want to concatenate Karen 0 plus gmail.com. If you print my string, you get concatenated value. If you need to add spaces between, let me say you want to say is karenzibo@gmail.com is my email. So if you want to add spaces, you have to add a space separately. Let's pause again. Then you add, it's my email address. So then you have this. But then there's something you can do to like make, there's something you can do to make this better. So if you do not want to like have all of these plus signs everywhere in your code, you can just do something called formatting. So let's say, okay, let me just do this. Okay. So let's say you want to put your email address. You just do this. Let me say my email is equal to Gmail. So you just do this. You just use these curly braces, like you put your curly braces to represent what value you want to be put there. And then you do dot format. Then you put in the variable you want to represent this particular curly braces here. So by the time you have, you see that it's going to like replace whatever was there. So formatting is like better compared to just like, if you want to concatenate, you can just keep concatenating. Let's say you have email, you have other variables that you want to plug into a string. Instead of doing plus email plus this plus that, you just format the string like this. And then, that makes it easier for you. And you have neat code. You can also loop through strings, just as similar to how you can loop through arrays or other mappings like that. So let's say you have this, you can use a for loop. You can use a for loop. Excuse me. Okay, just say for character in email, print character. So this is how you loop through your strings. That's how to do it. Then you can also like check if, I showed you how to check if a character or a phrase is in a value. So you just say if you want to check if this phrase is in email, just do that. And then if it is there, it prints true. Or if it is not there, then it prints false. And then you can also slice. So you can slice a string. What you just need to do is you use okay, let me just write it out. So you use square brackets again. You use square brackets like this, and then you put a column. So what is going to be before the column is where you want to start slicing, and what's going to be after the column is where you want to stop slicing. So if you do not put a value before, the value in the first, like before the column, it's going to start slicing from the first index. And if you do not put a value after like the column, it's going to go all the way through to the end. So Okay. Yes, right. Okay. 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 Sorry, let me just reshare my screen again. Just reshare, please. Excuse me. Okay. All right. Okay. So, please excuse me. So we're talking about slicing strings in Python. So we want to slice a string from, let's say we want to slice this email. So we want to slice this email. What we have to do is to use this, we have to use square brackets, and then we have to put a column between. So let's say you want to slice from the 0 index to, let's say, the 8th index. You just do 0 and then you put 8. But if you put 8, you are not going to like it's going to stop. Okay, actually 8, because if you do 0, 1, 2, 3, 8 is actually the 9th character. So okay, so that works. Okay. So then if you omit the first one, it starts slicing from the 0 index to the 8th one. So 1, 2, 4, 6, 8. Okay. Yeah. And then if you say you want to slice from 2 and then you omit this one, then it will slice from the second one, that's 0, 1, 2. That's from R down to the last one. Okay. So I think that's like everything about strings for now. There are still like other functions. There are still other functions that Python has provided, like for manipulation of string. But like these are just a few of them. So do you guys have questions that you want me to answer?
Yeah, I do. I actually have a question, but my question is on arithmetic operators because I remember that I was actually going through some things, I think some days back, and I got to realize that other arithmetic operators, there is something, there's this and sign, not arithmetic, sorry, assignment operators, where we do things like plus equals to, minus equals to. All right, so I got a bit confused when it was and equal to,
Okay,
and
so those ones are like, sorry, please continue.
okay, and equal to, the all sign equal to, the far greater than equal to, the far lesser than equal to, and also the caret equals to. I'm
Okay,
done.
so if you
Okay, I think Karen just dropped off. However, to answer your question, Mehdi, all of those are bitwise operators, right? So they are operators that happen on the bit level, right? So for each value you're working with, it's the bit value. So for example, if you're doing and, right, so it's doing a bitwise operation of an and on those values. So same thing applies to I think you make mention of
Sorry, please. I didn't hear your explanation on the and equals to. Can you take that again? Sorry.
okay, so Karen is back. Karen, do you get the question?
Yes, so I was telling him that, like, if you remember us in the slide, we talked about bitwise operators. So we have bitwise and bitwise or. So if you use any of those bitwise operators before the equal to sign, it's going to like, what it's going to do is like it's going to reassign that value to whatever values at the other side of it. But then it's going to now perform bitwise operation, not like arithmetic or. So we have the arithmetic one, plus, minus, floor division, ordinary division. But then if you use ampersand or any of those bitwise operators, it's going to perform bitwise operation on the two operands.
Okay. All right. Thank you.
Is there any other question?
Okay, so it seems like we're not having any other question, Karen.
Okay. So there are some assignments that I already have down for you guys under string operations. For the other ones, I think you guys can just like play around with them and try them out. But for string functions, like there are some assignments I want to give to you. I'll give it to you later in the Slack channel because my laptop is dead now. So by Thursday, we'll be able to like look at them together.
Okay, cool.
Okay, Molly,
Okay, I want to ask, the next class is Thursday, right? I just want to be sure.
yes, Thursday.
At the beginning, I had Tuesday. Okay.
Thursday, Monday and Thursday. So you have enough time to work on your assignments before Thursday. And if you need assistance, you can always like reach out to us.
Okay.
Okay.
Sorry, I just want to ask for myself that I won't be able to submit via the normal channel. Who am I to submit the assignment to? Is it yourself or just
Okay, what submit it through the normal channel?
I didn't get that. Sorry.
You'll be able to submit through the normal channel.
Yeah, I'm in the web front end, and from the last discussion with the Slack.
Okay, so Bisulu, can you be clear on you not being able to submit? Because I believe thus far we haven't given any assignments, and even if assignments are going to be given, a submission medium is going to be conveyed to us, right? And thus far, I don't think that has been done. And you're already reporting that you wouldn't be able to submit your assignments. So can you please throw more light on not being able to submit your assignments?
Okay, when the class was started,